Hello, in this video we are going to try to learn inverse function property. But before we try to learn inverse function property, I am going to try to basically remind you about composition of functions which we learned in our previous section. So I'm going to try to write down the definition of composition of functions. So composition of function. Composition of functions. Okay, so given two function, let's say I have given function of x and function gx, then composition of function f with function g, so that's how we write fog. So how we read fog? Composition of function f with function g is by definition is equal to function, and I put a parenthesis, and now the argument for function is basically the other function gx. So this is the definition of composition of two function. Okay, now we are going to use this formula in our inverse function property. So let us see the inverse function property. So we learned that that inverse of a function is only possible if the function is an one-to-one function. Let's say I have a function and I denote that function using a symbol f, and I know that f is a one-to-one function. So f is a one-to-one function. So that is given. So now the property will be so the number one property, of course, if f is my original function, and what will be my inverse function of f? Inverse function of f will be f superscript -1. Okay, so that is the symbol for inverse function. So now let us see the first property of inverse function. So composition of a function with its inverse. So composition of a function with its inverse function is going to be equals, so my first function and parenthesis, and then inside the parenthesis I have my the second function as an argument, and which will be actually going to be equal to x. And the second property is composition of an inverse function with its parent function f, argument x will be equal to, this time inverse function is going to be in the outside, and inside will be the original function of x is going to be equal to x. So these basically are two properties of inverse function. So what are the properties again? So composition of a function with its inverse function is going to be x, and composition of a inverse function with its parent function will be also x. So these are basically two properties of inverse function. Now let us see if we can write down the same conclusion using another example. Let's say, I have two functions. So let's say I have two functions. One function is f. So I have, let's say, two functions. One function is function of x, and let's say I have another function, any another function gx. Okay, I have these two functions, and now let's say I want to find composition of function f with function g, and by definition it is, and I found that this is of course by definition is what, f, and then inside argument will be what, inside argument will be gx, and I found that this is going to be, this is actually, I found it is 1 x, sorry, it is x. Now also I found that composition of function g with function f, by definition it is equals what, this time my function g is the outer shell, and in the inner shell, I have my fx, and I found that also this is equal to x. So let's regroup ourselves. We were given two functions. One is what, function of x, another is function gx. Now we found that composition of function f with function g is x. Also we found composition of function g with function f also equals x. So what can I say about the relationship between these two functions, function f and function g? We can say function f and function g are inverse of each other. So we can say g and f are inverse of each other. Are inverse of each other. So in other word, if I want to write down, so I can write g equals f inverse. Okay, so so that is basically the same property which we learned with f and f inverse. So now let us try to solve a problem. So let us try to solve a problem. So let me write down the problem. Let's say I have two functions. One function is function of x equals 2x plus 3, and let's say I have another function which is function gx, which is equals x minus 3 over 2. Okay, so these two functions are given. So what we need to do, we need to verify that these two functions are inverse of each other. So what we need to do, so verify, so what we do, verify that what, that g is inverse of f, or you know, f is inverse of g. So this is the problem statement, that we need to verify that these two functions are inverse of each other. So now again, if I want to verify that these two functions are inverse of each other, what I need to do, I need to find composition of these two functions. So what I am going to try to find first, I'm going to try first composition. So I am going to try to find first composition of function f with function g. Okay, so by definition, composition of function f with function g is what? It is I write down my function f, and I have my parenthesis, and then what is the inside argument? The inside argument is what? Gx. Okay, so that is by definition composition of function f with function g. Now let us see, 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 let us let us see. So let me write down let me use these same colors. So I have my function, okay, f, and I use parentheses. Now then gx, by definition, what is my gx? My gx is what? X minus 3 over 2. So let me write down x minus gx is what? X, let me use the same color. So gx is x minus 3 over 2. So this is basically now my what I found. Now let us see the definition of function of x. What is the definition of function of x? 2x plus 3. So I have what? 2, and then I supposed to have x plus 3. So this is the definition of my function of x. As you can see here, my function of x is what? 2x plus 3. Now I am interested in what? Finding not function of x, rather function of this argument inside here. This is the argument I want to find, which is what? X minus 3 over 2. So what I'm going to do, I'm going to replace x with x minus 3 over 2. So let me so let me erase this, and now let's write down what here? X minus 3 over 2. So let us see what is happening now. Now obviously we can see that these two and these two cancel out. So what I am left with? X minus 3, and then of course I have this plus 3 here, and this negative 3 and this positive 3 cancel out. So I am basically left with only x. So what I found that composition of function f with function g is what? Equal to x. So I am able to prove actually only the half portion here. So what I am able to prove? I am able to prove this portion, that composition of function f with function g equals x. Now I have to do what? Composition of function g with function f. So let us do the same thing here. So I'm dividing my screen. So we are going to try to find what? Composition of function g with function f. By definition it is equals what? First I have this time g and outside, and inside it will be what? Inside it will be function of x this time. So now let me write down my original function g, which is outside. So I'm keeping it as it. Now let us see what is my function fx. Okay, function of x. Now we know what is the function of x. We know function of x is 2x plus 3. So I'm going to write what here? 2x plus 3. Now let's see now what I have. I have only function gx. Now what is the definition of function gx, guys? So definition of function gx is what? Equals x minus 3 over 2. So I supposed to have what? I supposed to have x. And then minus 3 over 2. So that is my definition of function gx. Now in this case I need to find what? Not function gx, rather what? Function g2x plus 3. So I need to replace 2x plus 3 with x. So let's replace that. Instead of So I want to write here what 2x plus 3. So let me use the same color. So this is what 2x plus 3. Now so what I am end up with 2x plus 3 minus 3. So 2x plus 3 minus 3 over 2. So what I am left with, this 3 plus 3 and minus 3, this plus 3 and this minus 3 cancel out. So what I am left with 2x over 2. So 2x over 2 I basically get, which is equal to x. So what I get, I basically get that composition of function g with function f is actually equal to x. So let's summarize what I get previously. Previously I got composition of function f with function g equal to x, and here I got composition of function g with function f also equal to x. So what can I say? So I can say basically that function f and function g are inverse of each other. So function f and function g are inverse of each other, are inverse of each other. Or in other word, I can write g equals f inverse. So we prove that these two functions are inverse of each other. So that conclude our this particular example. Now we are going to look at another property of inverse function, which is symmetry property of inverse function. Okay, so let me write it down. So symmetrical property of inverse function. Of f and f inverse. Okay, so symmetry of f and f inverse. So let's say I have a function f. So I have a function f, and of course I also know the inverse of this function f, which is f inverse. Now let's say I am plotting this function f. So let's graph this function. So I know how to graph it. Let's say if I also graph that inverse function f inverse, I know how to graph it, and you are going to find that the graph of function f and graph of inverse function are basically symmetry with respect to the line. So these two graphs are symmetric about the line y equal x. Okay, so in conclusion, what can I say? I can say the graph of my function f and graph of my inverse function are symmetric about the line y equals x. All right, so let us see an example, okay, or application of this principle. All right, so let's start. So let's say, let me use a graph paper. So this is my x-axis and this is my y-axis. All right, so now let's say the graph of my function of x, say I have a point here which is no, not this point, it is say I have a point here, let's say this point is -3 and y equals -5, so that's the coordinate of this point. And let's say I have another point here which is -1, x is -1 and y is 2, and let's say I have another point which is 4, 3. X is 4, y is 3, and if I connect those points, what I found, all right, so this is basically my function of x. So this is what, this is plot of my function of x. Now I want to find what? I want to find inverse function. So what I want to find? I want to find f inverse. So this is my objective, and how I'm going to plot it? I'm going to using the symmetric property. Now so what I'm going to draw now, first I'm going to draw y equals x line. So actually y equals x line is nothing but this line. So y equals x line is basically, this is a straight line. So this is the y equals x line, this is a straight line, slope equal to 1. Now I need to find basically the mirror image of this red curve about this white y equals x line. Now you know, I am not going to make your life difficult, rather I'm going to show you a very easy way how to find mirror image about this. So what you do is, you see, take this point, what is x? X is -3, y is -5. Now flip it. For the mirror image, the x of mirror image of that point will be basically x will be -5. Okay, so x will be what? -5. X will be -5 and y will be -3. Okay, so the coordinate actually switch. So I already found mirror image of this point. Now let us concentrate on this particular point. Okay, for this particular point, my x is -1 and y is 2. So for the mirror image, my x will be 2 and y will be -1. So x will be 2, y equal to -1. So it will be somewhere here. So it will be x equal to 2 and y equals -1. Let's now look at the third point. So for my third point, my x is 4, y equals 3. So for the mirror image point, my x will be 3 and y will be 4. So it will be x will be 3 and y will be 4. So I already found all the 3 points. So now only thing what? I simply add these 3 points. So this is basically my inverse function, plot of my inverse function. So again, just to recap, simply to find a inverse function or a graph of the inverse function from the original function, what you do, you simply flip the coordinate of each x and y and find the other coordinate. Okay, so flip all these things. Okay, so that will be end of this video. So in the next video we are going to try to or I'll try to show you procedure of finding an inverse function, not using the graphical method but rather using equation method.